All right, here we are, about to start practice problem number 2. So you read about the significance level. Here we call the significance level alpha, and alpha comes up in our first practice problem. So we'll see that. You read about the test statistic. The test statistic is just a new phrase for the z-score. Statistics is its own animal. And so what we used to call the z-score, we're now going to refer to as the test statistic when we do a hypothesis test. And then you read the 5 steps of the test. Let's see them in action in practice problem number 2. Let me go ahead and read it again. A manager at Carl's Jr. wishes to know if the average salary of managers in the company is more than the national average of all fast food restaurant managers. The national average is $42,000 per year, but a random sample of 30 Carl's Jr. managers has a mean of $43,260 per year. Also, the standard deviation of the larger national population of managers is 5,230. At a significance level of alpha equals 0.05, is there enough evidence that managers from Carl's Jr. average more than $42,000? Okay. I've already shown you step 1 here since we really did it back in practice problem number 1. You always begin by stating the null and alternative hypotheses. So here they are. The null, we're going to assume the entire population of Carl's Jr. managers really does equal 42,000. The alternative is that they average more than 42,000. Notice we use 42,000 both times. Okay, so we do have that other number, right, 43,260, but that is a sample average. And so that's what, like, the means of the evidence. But the alternative, really all we're thinking is, do Carl's Jr. managers make more than this? Okay, so we always see in any of these problems for the hypothesis test, that number is always going to be the same. The only thing that changes is it equal, or maybe it's a more than, sometimes it's a less than, sometimes it's a not equal, but that number is always the same. Okay, let's move to step 2. Calculate the test statistic from the sample data. Okay, so now we look at the sample data. The sample of 30 Carl's Jr. managers had a mean of 43,260. We're going to find the z-score here. X bar is that sample average. There's where the 43,260 comes in. And we know it's a sample n of size 30. So we're going to find the z-score that goes with these. How do we do that? It's the same formula for the z-score as the central limit theorem, right? When we divide by the square root of n. Right, x bar minus mu sigma square. Okay. So here we've got our x bar, we've got our n. Mu will be the 42,000. And remember, we're assuming that mu is equal to 42,000. And then they tell us the value for sigma as well. So let's put all that in there. And this will finish step 2. So we've got our x bar, the sample average, minus the assumed average for the population, the population standard deviation divided by square root of the sample size. And I went ahead and rounded that to 2 decimal places because that's what we usually do with the z-score. And that's what we're now going to call our test statistics. Test statistic. Okay. All right, that's step 2. Step 3, find the p-value. All right, so the p-value is simply the probability that comes from this z-score. All right, same way we did it before. We're just giving things new names. Some students get frustrated with that. Other students are like, oh, great, it's actually something that I already know. Some people don't like things getting new names. Well, but the concept is really what's tricky, right? Okay, so we'll take that test statistic. That's our z-score. We're going to find the probability of that z-score. But now a key moment here, I don't want to go over it too quickly. What inequality here? So our p-value will equal the probability that capital Z, should it be a greater than or a less than our z-score? That's going to change that p-value a lot depending on that inequality. And so I'll give you a hint here. Look back to your alternative hypothesis. It always is going to match. So if I have a greater than here, I want a greater than there. I want the probability that Z is greater than that number. That z-score of 1.32. Okay, at this point, we're not going to use our table of z-scores. We're going to use the Statcrunch normal calculator. So go ahead, if you haven't pulled up Statcrunch already, maybe pause the video, pull up your Statcrunch, get to your normal calculator, and just make sure that you type in 1.32 here for the Z, and change this into a greater than. I want to say the default is a less than. I think they actually use or equal to, which I disagree with. I guess, well, I won't get into it. If it's an or equal to, use the or equal to. Use that, hit enter, see what you get. I believe they give it to you to 4 decimal places, and confirm that you get this p-value, 0.0934. Okay. If you got that p-value, then you did it right. Okay. That is step 3. We found the p-value. At this point, you could argue the math is really done. Step 4 and 5 are just interpreting this p-value that we got. So step 4 is compare the p-value to the significance level. Okay, finally in step 4, this is when the alpha comes in. Okay. Oh, fly coming to visit. So you've got your p-value, and they said way back, right in that last sentence in the question, at a significance level of alpha equals 0.05. What does that mean? Okay, I'll show it to you in a graph here in a moment. What we're going to do now, we're going to compare these two numbers, and the question is which one is greater? Which is the bigger one? And in this case, of course, the p-value is bigger. 0.09 is bigger than 0.05. Okay, that's so we want to identify that correctly. What does that mean? Okay, in step 5, which I guess is part E, the way I set up the question in the lecture. Step 5 is decide to either reject the null hypothesis or fail to reject the null hypothesis. So again, this would be a nice, it would be nice if we were all in class together and I could say, hey, you guys, if the p-value turns out to be the bigger, should we reject the null hypothesis, meaning rejecting the null hypothesis would mean saying, no, they don't really make 42,000. They must make more than 42,000. Or do we fail to reject the null hypothesis? If we fail to reject, then we don't have enough evidence, so we're just going to stick with it, if you will. So, right, can't really vote on that the way we're doing the video. I wouldn't be surprised if there'd be people on either side. Here's what it is. Oh, we had done step 4. The answer to step 5 is we fail to reject the null hypothesis. Like, oh, that's interesting. Maybe you thought that it was the other way. Here's why. Think of that language of, someone in front of a jury, right? When the jury comes back with their decision, right, we've seen it in movies at least, somebody walks out with like the the head juror walks out, with an envelope, and they hand it to the judge. They hand it to the bailiff, and then the bailiff hands it to the judge, right? So the judge then opens up the little piece of paper, and what's he going to say? He's either going to say, "We, the jury, find the defendant guilty," or "We, the jury, find the defendant not guilty." Okay, and notice the sensitivity in the language there. They never say, "We find the defendant innocent." Okay, they either say, "We find them guilty," or "We find them not guilty." Here, we found the null hypothesis not guilty. We failed to reject it. There was not enough evidence to reject. Like reject would be like guilty. There's not enough evidence to reject. There's not enough evidence to find guilt. Okay, why would this p-value, bigger than the significance level, why would that result in not enough evidence, not guilty, fail to reject? Okay, let me show you a drawing. Okay, so the question is why? So I've drawn a bell curve. Okay, we assume that mu there at the middle is 42,000. Okay, and I have shaded the significance level of 0.05. We shaded above because we're questioning whether these people, these managers, really make more than the 42,000. So the more than tells us to shade this up here. All right. Then the question is, what we really were saying a moment ago, does P equals 0.0934, does it fall inside or outside that shaded region? Okay. If it falls inside, then we have the evidence. We have gotten far enough away that we've got enough evidence. If we don't make it that far, if we fall out here, then we don't have enough evidence. Okay. Well, P equals 0.09, this is like the top 5%, right? P equals 0.09, that's over 9%. We did not make it into the top 5%. So this is the 43, what was it, 260, which is, it's, and the p-value that goes with it. You might say, yeah. So these two are connected, right? There's, a little over 9% above this one, right, with the greater than. So our average from our sample was not evidence enough that Carl's Jr. managers really do make more than this number. It's some evidence, no doubt, but not enough evidence to convince us to err away from this number. Okay. All right, I see in part E there it says, interpret the decision in the context of the problem. Okay, so here's what we would say. I'll just show you. The interpretation, this is maybe what the judge would read aloud. There is not enough evidence that the average Carl's Jr. manager has a salary more than $42,000. No doubt there's some evidence, but there's not enough for us to get into that top 5%. Okay, if this is still not clear, here's another way of looking at it. We decide before the problem starts what value to give to that alpha, right? And kind of like 95% is the go-to significance level, alpha equals 0.05 is the go-to significance level. The top 5%. If that sample average can make it into a p-value based on the sample size and based on the standard deviation, if that can make it up here, we've got enough, right? Here's what's going on. So we assume all Carl's Jr. managers make this much, right? Because that's what all fast food managers make. Now we know perfectly well Carl's Jr. is probably going to be a little bit different one way or the other from all fast food managers, right? So we actually, this is our best guess, but we're not surprised when it's a little bit higher, a little bit lower. So what we're saying is, okay, we're going to assume Carl's Jr. managers make this much. But if in our sample average gets so far up that it lands into this shaded region, the chances of that happening are low enough, they're beyond our significance level. The chances of just any random sample of 30 managers getting an average in here is so low that it's probably this that wasn't true in the first place. For Carl's Jr. managers, if we just pick 30 of them and they land in here, this probably wasn't really the average for the Carl's Jr. managers in the first place. So we reject it. Maybe that makes a little bit more sense to you. Hey, bring your thoughts to the Zoom session, and we can maybe chat about it there as well. I think I'm going to stop this video here. We've already coming up on 17 minutes. We will do practice problem number 3 in the next one.